Okay, things are up and running, so I'm going to take you through 3 examples, one of each of the tests, along with the split file function and capturing and measuring effect sizes in Cohen's d and r squared. First example, this is from the homework assignment from last week, but just kind of take you through step by step. An educator wants to know if students from high SES families have higher levels of motivation than the general population, who has a mean of 0.240. So because I have my population mean given and no population standard deviation, I know that it is a one sample t-test. I'm not going to go over the null and the alternative. I think you guys are pretty comfortable with that, so I'm not too worried about it. The write-up is down here. We're going to run the analysis first, just to take you through. So we need to find our data set, and this is going to be off of, I think, the small sample. Yeah, I can do this. HSB. I have my SES variable here, right? And I am looking at motivation scores. Now, one of the things is that I have different levels of socioeconomic status here. And if I want to know what they are, right, I can look at my value labels and see that I have lower, middle, and upper. Otherwise, I can go to variable view, find SES, look at the value column, and click on the right side, and it'll show me the different values. Go back to data view. If I want to then split my file, I go to the data drop-down menu, split file, compare groups. I want to compare it by socioeconomic status. Make sure that this is highlighted. I have my group in there, and click OK. These are just results. I can get rid of these and do them again later. Now I have split the file, so I can run my analysis, and I'm going to go to compare means, a one sample t-test. I'm going to put motivation in my testing variable, and my test value is that population mean that was given to me. I click OK, and I see that just for my upper students, right, I have a t-value of 6.3, 18 degrees of freedom, and a p-value of 0.000. Here are my one sample stats, my mean, my standard deviation, my standard error, and so on. And so I will be able to use this when I'm making my table and graphs. According to this, because my p-value is less than 0.05, I reject null and say that students from high SES families do have motivation that is higher than the general populations. Now, if I'm going to write this up, right, my first sentence is a one sample t-test was conducted to determine, and then basically I'm going to have an if my alternative hypothesis, if students from high SES families have higher levels of motivation than the general public or general population. I'll fix that. That's all there is to writing that first sentence. Second sentence, results indicated that students from high SES families do have higher motivation than the general population. Now I back it up with my stats. This is my T and my degrees of freedom. This is my T value and my P value. And the thing we're adding now for the exam is with a large effect. I want you to calculate an effect size. You can do either Cohen's d or r squared. That's up to you. For an independent samples, if you're going to calculate an effect size, you have to calculate r squared. We're not working with Cohen's d for that one. And then I need to make sure that I deal with any issues or violations of normality. Now I have to look into those first. So I'm going to go back to my data. I already have split my data, right? So I have just my I have my socioeconomic status groups being analyzed separately. I'm going to go to Analyze, Descriptives, and Descriptives. I'm going to put motivation in my variable, click Options, select Skewness and Kurtosis. Click Continue, click OK, and now I have my data. And I see that there is a minor violation in skewness here. So if I go back to my file, I have to make sure I have the right thing in here. Skewness equals negative 1.15, so results should be interpreted with some caution. Don't know what this horizontal category axis thing is here, but hopefully it won't show up on your video. If I want to create my table and my graph, I can go into Excel, and I'm taking this data from I'm going to wrap the text here, from my output. Right, and so for my table, I have my high SES students, my general population, motivation of students from high SES families, and then I have the values that I'm getting. This was my population mean that was given to me. This was the descriptive mean that was given to me when I ran my analyses, right here, 0.737. I could round that up to 0.74 if I want to. Now, when I highlight this, in Excel on Windows, you would go under the Insert tab, but if you're on a Mac, you go under the Chart tab. We're going to insert a column chart. Basically, it's exactly looks just like this. I can copy and paste that into my document and shrink it down. If I want it to be a little taller, I can make it a little taller. That gets off the page though, so I'm going to shrink it down to make it fit. Make it a little bit bigger so I can get a little more detail in it. But otherwise it's fine. Remember, if you want extra credit points, you can make the graphs even more beautiful. Create some funky graphics. Do whatever, just to liven it up a bit. Now, going back to calculating Cohen's d, the formulae for these are in the effect size notes. You can do it in Excel, and basically it is our mean difference that we see between our sample mean and the population mean divided by our sample standard deviation. And if I'm looking at my output, right, I have my mean and standard deviation. This is what I'm looking at for the standard deviation. My mean difference, however, is down here, right? 0.497, about 0.5. I'm going to put that in here, right? I'm going to put my standard deviation in here, and then I'm going to hit equals this cell, if I click in here, right, divided by this cell. Hit return, and it gives me my Cohen's d. Anything over 0.8 is a large effect, and that's what I end up putting in my write-up with a large effect. Italicize the d equals 1.44. I'm going to mention my minor violation and say that results should be interpreted with some caution. So hopefully this kind of gives you a view of everything you need to do in terms of splitting the file, writing things up, and gives you a structured example to work off of. If we were going to be doing independent samples t-test, and scroll down to this one here. All right, an educator wants to know if students in large schools have higher social ability scores than students in small schools. Again, here are my null and alternative because I have two different groups, large schools and small schools. I'm going to do an independent samples t-test. Write-up and tables and everything are going to be in the same format. I just need to run the analysis and run the diagnostic stuff just to make sure. If I go to my file, and this is my HSB 3.1 file, right, I have my school size over here. If I want to view my value labels, I see that I have 4 different types: small, medium, large, and large. In this case, I just want to look at the small and the large. So what I'm going to do is I'm going to go to Analyze, Compare Means, Independent Samples t-test. I'm going to put my school size in my grouping variable. Social ability goes in my testing variable. Again, I need to when I define my groups, I'm comparing only those two groups that I care about. Even though I have 4 different school sizes, I'm going to compare only the smallest schools with the largest schools. So group 1 versus group 4. I click continue, I click OK, and I get some new data. Right now, when I look at this to make my decision, I have one further step in that I need to look at whether or not the variances of small schools and large schools are actually equal. And I'm looking here at this p-value in particular. If it's bigger than 0.05, I stay in the top row. If it's smaller than 0.05, I would use the data or the results in the bottom row, right? The top row is saying that equal variances are assumed. In other words, because I didn't reject the null, I'm saying that actually the variances are similar. So I stay in the top row. I look at my t, my degrees of freedom, and my corresponding p-value. Because this is bigger than 0.05, I fail to reject the null. And I say that there's really no difference in the social ability of students from different sizes of schools. Well, actually, we'll go to the write-up first. So when I'm writing it up, I say an independent test was conducted to determine, restate my alternative hypothesis, and then I say what I found, with backing up my t-stat, or my results with my t-stat, degrees of freedom, and then my p-value. Now, in class, we have been calculating the r-squared and the Cohen's d, regardless of whether we reject or fail to reject. But what I'll say now is that if you fail to reject the null, in other words, if I'm saying there's no difference, I don't need to calculate the effect size because there's no effect to calculate. What I'm saying is that the two are actually the same. However, if I did want to calculate it, this is how I would do it. I would take my t value and my degrees of freedom in order to calculate r squared. And the way that I would do that, I would take those two values, put them in Excel. Here's my t value. Here's my degrees of freedom, right? And if you look in the notes again for effect sizes that we looked at this past week, the formula for r squared is t squared divided by t squared plus degrees of freedom. Well, this is t squared, right? It's 1.346. The caret is the square or exponential symbol in Excel to the second power that's squaring it. That's 1.811. The bottom is then 1.811 plus my degrees of freedom, which are 38, and that gives me 39.811 and so on. And then r squared is just dividing this by this. And if you look at here, right, C19 divided by C20, that's my r squared. If I were going to put it in here, if there was an effect, I would put a comma and say with a small effect, and then I would put r squared, my exponent in there, equals 0.05 rounded up. And then I would italicize this. Now, because there is no effect, I'm not going to do it. Also, because there is no effect, I am not going to even worry about looking at the skewness and kurtosis stuff in this case. Usually that's just stuff if I'm going to say that something is going on. If I looked at it and there was stuff going on and I had this failure to reject, but I thought the means were somewhat different, then I might look into it and I might mention it. But for, that's kind of beyond the scope of this particular class. Making my table and my graph are just the same, so I don't feel like we need to go over that. Final example will be the paired sample t.